Welcome to the Mathematics of my channel. In this video, we are going to solve this interesting integral. Integral from 0 to infinity e to the minus here 2 by 2 matrix 2 1 1 2 times x square dx. Okay, how to begin? Well, first here we have exponential of a matrix. In a previous video, we discussed about exponential of a matrix, but for your understanding in this video, now I am going to also find the exponential of a matrix again. Okay, now if we have a diagonalization matrix A, so we know A is equal to P D P inverse, and then we are going to take the power of a matrix. So if we take a to the n, we know this is equal to P D to the n P inverse. Then we know the power series of e to the x is equal to 0 to infinity x to the n over n factorial. Okay, then instead of x, now I am going to plug in a. So e to the a is a 2 by 2 matrix. So e to the a is equal to sum of 0 to infinity. Here now we have a to the n over n factorial. Okay, then infinite sum 0 to infinity. Now a to the n we know p d to the n p inverse over n factorial. Okay, now we can rearrange this like p times infinite sum here d to the n over n factorial times p inverse. Okay, then here p, now sum of 0 to infinity. Now if we take the diagonal matrix d is equal to here a 0 0 b. Now we know d to the n is equal to a to the n 0 0 b to the n. So we can plug in here. Now we have here 1 over n factorial. Instead of d to the n, we have a to the n 0 0 b to the n here p inverse. Okay, then we can write this is equal to e to the a is equal to p times now here matrix. Now a to the sum of sum of 0 to infinity a to the n over n factorial. Here 0 and here also 0. Here we have sum of 0 to infinity b to the n over n factorial, and here p inverse. Okay, then here p, now we know here this series is equal to e to the a, this definition. So here we have e to the a 0 0, this is equal to e to the b times p inverse, this is equal to e to the a. Okay, now we defined exponential of a matrix, and this is very nice equation. Okay, then let's move to our question. Now we have e to the this 2 by 2 matrix. So now a is equal to, I'm going to take a 2 1 1 2, and now we are going to find the eigenvalues. So we know a minus lambda times I is equal to 0, and then we know here 2 minus lambda, here 1, here also 1, here 2 minus lambda is equal to 0. Now if we simplify, here we have 2 minus lambda square minus 1 is equal to 0. So we know 2 minus lambda is equal to plus or minus 1, then lambda is equal to 3 or lambda is equal to 1. Now we know the eigenvalues are 3 and 1. Okay, then we are going to find the eigenvectors. So when lambda is equal to 3, when lambda is equal to 3, null space of the matrix, we know lambda is equal 3. So here we have minus 1, then 1, minus 1, 1, again 1, minus 1. So now some simplification of rows. Now we can write here minus, no, we can multiply by minus 1 row 1 and then subtract row 1 from row 2. So here we have null space of 1, minus 1, 0, 0. Okay, here we have the reduced row echelon form of the matrix, and now we can write this is also equal to 1, minus 1, 0, 0, vector xy is equal to 0, 0. So we know here x minus y is equal to 0, so x is equal to y. Then we know we can write span of here 1, 1. Okay, then we should find the eigenvectors when lambda is equal to 1. So when lambda is equal to 1, we know null space of matrix is equal to, when lambda is equal to 1, 1, 1, 1, 1. Yes, 1, 1, 1, 1. Okay, then here also we can simplify, so we can write now this is equal to null space of 1, 1, 0, 0, 1, 1, 0, 0. Then we can write 1, 1, 0, 0, vector xy is equal to 0, 0. So we know x plus y is equal to 0, so x is equal to minus y. So the span of now minus 1, 1, minus 1, 1. So now we have eigenvectors. So the matrix of the corresponding vectors, we can write P is equal to here the span of 1, 1. So 1, 1, minus 1, 1. Okay, now here we have P, and also we know D, matrix D is equal to our eigenvalues 3 and 1. So 3, 0, 0, 1. Okay, then we can write e to the a. We know the formula e to the a, exponential of a matrix e to the a is equal to p times here e to the a 0, 0, e to the b times p inverse. Okay, then so we can write here e to the, now we need to e to the minus a times x square. So e to the minus a times x square is equal to p, we know p 1, 1, sorry 1, minus 1, 1, 1, and d we know here d, here we have e to the a, so here 3 and here minus ax, so we can write e to the minus 3x square, here 0, here also 0, here e to the minus x square times p inverse. So inverse of this matrix, sorry, inverse of this matrix, we know here 1/2 times here 1, 1, so 1, 1, and here 1, minus 1. Okay, now we need to simplify. So here 1/2, after the simplify we will have e to the minus 3 times x square plus e to the minus x square, and here e to the minus 3 times x square, minus e to the minus x square, here e to the minus 3 times x square minus e to the minus x square, here e to the minus 3 times x square plus e to the minus x square. Okay, then our integral from 0 to infinity e to the minus here 2112 x square dx is equal to 1/2 integral from 0 to infinity, here we have e to the minus 3x square plus e to the minus x square, here e to the minus 3 times x square minus e to the minus x square, and here e to the minus 3 times x square minus e to the minus x square, e to the minus 3 times x square minus plus e to the minus x square. Okay, and here dx. Now we should integrate this. Here now we can write integral sign, integral from 0 to infinity this part, integral from 0 to infinity this part, like this. But here we have now 0 to infinity e to the minus x square, we know. Integral from 0 to infinity e to the minus x square dx. This is very famous integral, Gaussian integral. We know the answer is square root of pi over 2. Also we need to integral from 0 to infinity e to the minus 3 times x square dx. Okay, to evaluate this integral we can use a substitution. So if we take square root of 3 times x is equal to t, then differentiate, square root of 3 times dx is equal to dt, and now we can write this is equal to integral from limit also 0 to infinity and e to the minus 3x square. So we know e to the minus t square and dt over square root of 3. Now we know this is equal to square root of pi over 2 times square root of 3. Okay, then we can write our integral is equal to here 1/2. Now e to the minus 3 square, integral of e to the minus 3 square, we know square root of pi over square root of pi over 2 times square root of 3. Then e to the minus x square, we know square root of pi over 2, and here also square root of pi over 2 times square root of 3 minus square root of pi over 2, and here square root of pi over 2 times square root of 3 minus square root of pi over 2, here square root of pi over 2 times square root of 3 plus square root of pi over 2. Okay, then we can take square root of pi over 2 as a common factor. So here we have the square root of pi over 4, the matrix. Now if we simplify here, 1 over square root of 3 plus 1, so 1 plus square root of 3 over square root of 3, here 1 minus square root of 3 over square root of 3, and here 1 minus square root of 3 over 3, here 1 plus square root of 3 over square root of, here square root of 3, here also square root of 3. Okay, this is the answer. If you like this type of videos, please subscribe this channel. Thank you for watching.